Kia ora, and welcome to a lesson on Cambridge Mathematics P3 Binomial Expansion, where n is not a positive integer. Okay, so you may remember binomial expansion from P1, and one of the things from binomial expansion at P1 was you had 1 plus x to the m, and you're able to say that that is equivalent to NCR, where n and the r are n and 0, plus n1 x plus n2 x squared plus n3 x cubed plus so on and so forth until you get n x to the n. Okay? And this is just the 1 plus x to the n expansion, not the more complicated a plus x to the n expansion. We're only going to be looking at this for the purposes of n is not a positive integer expansions. Another way of writing this is as what the NCR is actually doing. So n0 is equivalent to 1. Is always equivalent to 1, plus n1, which is always equivalent to n times x, plus n2, which can be rewritten as n minus 1 over 2 factorial times x squared, plus n3, which can be rewritten as n minus 1 n minus 2 over 3 factorial times x cubed, so on and so forth, until you get x to the n. Okay, this is a terminating series. Okay, and it's a terminating series and true when n is a positive integer. Okay, so it terminates when n is a positive integer. When n is not a positive integer, there's a slight amendment to the way this looks. Okay, but it follows from this one here. Okay, so when n is not a positive integer, then 1 plus x to the n can be written as 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed, and so on so forth, infinitely. Okay, so there's no terminating x to the m. So this is only true where n is rational, so we can't have an irrational value for n, and the modulus of x is less than 1. That's the only times that this expansion is true. Okay, so one of the key things to take away from this is that this series is infinite. Okay, it's never going to terminate. So if you've got a non-positive integer, theoretically this expansion will go on forever. Okay, the questions you get asked will not want you to go on forever. Obviously, they'll ask for specific terms or for you to calculate an unknown in some way, some forth. And that's how these questions are going to be posed to you. The other key thing is the modulus x is less than 1. That's really important. The expansion is only valid when that is true. And you'll often get asked to calculate when the expansion is valid. So the expansion is only valid for modulus x is less than 1. Okay? So, we're not going to go over a proof of this because that's beyond what we need to be able to do in this course. So we're going to look at this put into practice, this form here. So let's do that with these two different ones. We've got 1 plus x to the minus 3, and we've got 1 plus x to the half. Okay? So if I want to expand 1 plus x to minus 3, that's going to start off with 1, as it always does, plus my n, which is minus 3, lots of x, plus n minus 1 over 2 factorial, which becomes minus 3 minus 1 over 2 factorial, times my x squared term, plus n minus 1, n minus 2, which is minus 3 minus 1, minus 3 minus 2 over 3 factorial for my x cubed term, and so on and so forth, infinitely. Okay, which you can then just simplify down to 1 minus 3x plus 6x squared minus 10x cubed plus so on and so forth. Okay, so the ability to do that is one of the key skills. Let's do it with the second one. So all I'm doing is replacing my n in this case, and later on we're going to be looking at when the x is slightly different to just the x, because we might have a 2x squared or a minus 3x as our x instead. Okay, which is going to be our next two examples. So when x is a half, we've got 1 plus our n, which is a half, lots of x, plus n minus 1, so half minus 1 over 2 factorial, lots of x squared, plus n minus 1, n minus 2, plus half minus 1, half minus 2 over 3 factorial, lots of our x cubed, and again, so on and so forth. Okay, you then will simplify this to become 1 plus a half x minus an eighth x squared plus a 16th x cubed, so on and so forth. Okay, so this is where the n is a negative or a fractional power, but the x is still just a single amount of x. Okay, now we're going to look at some actual questions surrounding this. So we're going to do expand 1 minus 3x to the power minus 2 in ascending powers of x up to including the term x cubed, and state the range of values of x for which the expansion is valid. So our n is minus 2, but this time our x is going to be replaced with minus 3x. Okay? So we've got the expansion, which will start, 1 plus 3x to minus 2. Our expansion starts off with 1, always will start off with 1, plus our n, lots of our x, so n is minus 2, our x is now minus 3x. Okay? Plus our n minus 1 over 2 factorial, so n is minus 2, n minus 1 is minus 2 minus 1 over 2 factorial, times by our x value squared. Okay? Plus n minus 1, n minus 2, so n minus 1, n minus 2 over 3 factorial times our x, which is now minus 3x cubed. Okay, and again it would carry on, but it's only asked us to go up to the cubed part of this. So now we've got here, we just need to simplify this down. So expanding the brackets and simplifying the fraction, that is going to give you 1 plus 6x plus 27x squared plus 108x cubed, so on and so forth. Okay? So that's the first part. Expand 1 minus 3x to the power minus 2 in ascending powers of x up to including the term x cubed. All I am doing is replacing my n and my x in my generalized form which I wrote here. Okay? So you just need to get into the habit of using that form, starting off with 1 plus n, then it's n minus 1, then it's n minus 1, n minus 2 over the factorials of 2 factorial, 3 factorial, and the powers are increasing at the same time. The power is the same as the factorial each time. I could have written this as over 1 factorial, but that would have been pointless, because 1 factorial is 1. Okay? So, what's the last part? The last part said, and state the range of values for which the expansion is valid. Well, as I said earlier, the expansion is only valid when the modulus of x is less than 1. Rx is now modulus 3x, so this is only true when modulus 3x is less than 1. Okay? But we want to write this as an x, not as a modulus minus 3x. So, how do I get modulus x? Well, when I've got modulus minus 3x, if I'm trying to get rid of that minus 3, I can't think of it as dividing by negative 3, because modulus minus 3x is equivalent to modulus 3x is less than 1, because the modulus negates the negative aspect of it. So when I'm dividing by negative 3, all I'm actually going to be doing is dividing by the positive 3, which will give me modulus x is less than 1/3. Okay? So that is the first question done on this topic. Okay. Example 3. Find the first 4 terms in the expansion of 1 plus 2x squared to the power minus 4 and state the range of values of x for which the expansion is valid. So we're doing the first 4 terms, which is the same as up to the x cubed term, because the first term is 1. Okay. So don't forget that 1 is a term. So let's write this out. Oh, sorry. Our n, what's our n this time? Our n is minus 4, and our x is going to be replaced with 2x squared. Okay. So 1 plus 2x squared to a minus 4 is equivalent to our first term, 1, plus our n, which is minus 4, lots of our x, which is now 2x squared, plus our n minus 1, which is minus 4 minus 1 over 2 factorial, times by our x value, which is now 2x squared, but then squared. And this is our fourth term now, is our n minus 1, n minus 2, over 3 factorial, lots of our x, which is now 2x squared, but cubed, so on and so forth. Okay? Now you just need to do your expansion and simplification of all this, which is going to give you 1 minus ax squared plus 40x to power 4 minus 160x to the 6, so on and so forth. Okay? When is this expansion valid? Well, it's when our x, which is now 2x squared, is less than 1. So modulus 2x squared is less than 1. So that would be modulus x squared is less than a half, and then the root of a half. Okay, I don't need to take the negative root of a half, I only need to take the positive root, because I can't have a negative value when I'm looking at modulus. So whenever you're doing these, your normal thing would be when you square root you say positive, negative. but here you can't. This can be rewritten as modulus x is less than 1 over root 2, and that's a better way of writing it because you've simplified that root 1 to just being 1. So this is the best way to write when x, or for what range of values of x for which the expansion is valid. Okay, so again, just expand, replacing your n and your x value, and then to find where it's valid, make the new x value be less than 1, and then solve the way you would with any other modulus. Okay, next one. Okay, and this time it's not so evident that it's a binomial expansion. They've tried to write it in a slightly different way, but it's still a binomial expansion. It says find the coefficient of x cubed in the expansion x minus 5 over 1 plus 2x. So the first thing to do is to rearrange x minus 5 over 1 plus 2x to x minus 5, 1 plus 2x to the minus 1. Okay, so what we're going to do is we're going to do the binomial expansion of 1 plus 2x to the minus 1, and we're going to multiply that by x minus 5. But 1 plus 2x to the minus 1 is infinite. Okay, so you don't need to go on forever because it specifically asked you to find the coefficient of x cubed. So you need to think what powers in the expansion of 1 plus 2x to the minus 1 when multiplied by the x minus 5 term, so expanding the brackets, will give you the x cubed coefficients. Okay, so that will be, in this expansion, the x squared and the x cubed, because when I multiply this expansion by x, it's going to give me x squared times x, which will give me an x cubed term. And when I multiply this expansion by minus 5, it's going to give me an x cubed term. So I know I don't need to go past x cubed in this expansion. So let's have a look at what this will look like. So x minus 5, 1 plus 2x to the minus 1 is equivalent to x minus 5 multiplied by then the expansion, which is 1, plus our n, which is minus 1, lots of our x, which is 2x, plus our n minus 1, minus 1, minus 1, minus 1, over 2 factorial, times our x, now squared, plus minus 1, our n minus 1, n minus 2, over 3 factorial times our new value of x cubed, so on and so forth, but I don't need to go past x cubed because I only need the x squared and the x cubed term. So what I'm going to do is I'm going to multiply my x squared term by x, and I'm going to multiply my x cubed term by negative 5. Okay, and those are going to give me the two different terms involving x cubed. So I'm going to do x multiplied by minus 1, minus 1, minus 1 over 2 factorial 2x squared, and I'm going to do minus 5 times minus 1, minus 1, minus 1, minus 1, minus 2 over 3 factorial 2x cubed. Okay, the top one is going to give me the x term, which would be minus 1 times minus 2, which is positive 2 over 2 factorial, which is 1. 2x squared is 4x squared, so that's 4x cubed. And then minus 5 times this, so I've got minus 6 over 3 factorial, which is minus 1, times by 2x cubed, which is ax cubed, so that becomes minus ax cubed, times by minus 5 is 40x cubed. So the combination would be 44x cubed, so the coefficient of x cubed is 44. Okay, so it's very similar to some of the questions you would have done last year with the expansion, with a binomial expansion multiplied by another bracket. It's just this time your series is infinite, but you still just need to identify what terms are going to produce the coefficient, what terms, multiplied terms, are going to give you the term that you care about, so you can find the coefficient. Okay, that is everything that I'm going to cover today. Hopefully you understood that and you can have a go at some questions yourself now. Good luck, and I'll speak to you again soon.